The first thing I wanted to find is this guy. This is a ray. An array has a point, and then it continues on as far as it can go. So this is a ray. Vertex. A vertex is a point where two rays meet. A vertex is a point where two rays meet. So we have one ray right here. I'm going to add another one. And those two rays now form an angle. The question I'm giving to you today is, can we describe the difference between a vertical and an adjacent angle? We'll get to that at the end when we start defining more terms. So, here we have an angle which is made up of two rays. And we have different classifications for our angles. And some of you may have seen these before. The first one is when your two rays are perpendicular. That means they meet at a 90-degree angle, straight up and down, and then straight across. This is a right angle. And this right angle is marked like this. We put a little square inside the angle itself to show that one line is perpendicular, to show that they meet at a perpendicular point, and they meet at exactly 90 degrees. So a right angle is exactly 90 degrees. That's the first angle that I want to cover. The second angle that I want to cover is one that is less than 90 degrees. Anything that falls before our rays meet on a perpendicular plane, anything that falls before this 90-degree line is an acute angle. So we're going to write here an acute angle, and an acute angle is anything less than 90 degrees. And again, many of you have seen these before. That's an acute angle. We also have the opposite. If it is more than 90 degrees, it's no longer an acute angle, but an obtuse angle. This is a straight angle. And a straight angle measures at 180 degrees. Notice that it is exactly double 90 degrees, which was my right angle, going straight up and down. But that's a straight angle. Okay? Now I'm going to talk about how we name angles. So we have some angles formed by the crossing of these two lines. We've got a vertex right here. This one goes on forever, and this one goes. These lines are meeting. We got a vertex. So now we can talk about naming some of these angles. So let's put some points on it. We'll say this is A, this is B, and this is C. So you can call this angle, this one right here, angle. And when I say angle, I want you to write the angle sign, which is this guy right here. This is my sign for angle. We can call this guy angle A, B, C. It's the angle formed by A, B, and C. We can also call it angle C, B, A. The angle formed by C, B, and A. We can also just call it angle B. Sometimes, because these letters fall on the line of the vertex, you can actually have a mark, a number or a letter to represent this entire angle right here. So what they'll do in that case, let's say they put a little 1 right here. That represents the space in between BA and BC. That little 1 right there. So we can also call this guy angle 1 if they have a number where the measurement should go. Now that we've covered the 4 different ways to name an angle, I want to do 2 more words that describe how we look at these angles on this display. The first one I want to cover is a vertical angle. A vertical angle are 2 angles that are opposite each other. Two angles that are opposite of each other when 2 lines intersect. Just like we have here. So in our example, we have 2 lines. I'm going to put a D over here to help us make some sense of it. So we have line DC, and we have line, I'm just going to call this line A. And line A goes through this B and it keeps going. So we have 2 lines, and we have this angle 1, and it has a vertical angle, the angle that is opposite to it. And that's going to be this guy right here. This 2. They're opposite to each other. And when 2 lines intersect, this one and this one are both vertical angles. They're opposite of each other. Do we have any more vertical angles? We do. And I'm going to put an E right here so we can define 2 vertical angles. 2 examples of vertical angles. ABC and DBE. We also have ABD and CBE. These are also vertical angles. Sorry about that. Vertical. That makes more sense. Vertical angle. Sorry about that. All right. Now that we fixed that, vertical is one type of angle. The other one is an adjacent angle. Now I gotta spell the word adjacent. I think that's right. And adjacent angles are 2 angles that have a common vertex. In this case, our vertex is B. That have a common vertex, a common side, and don't overlap. In other words, they're next to each other. So, DBA and ABC are adjacent angles. They're next to each other. DBA and ABC are next to each other. Now, let's put our globe back. if a circle is 360 degrees, that means that this straight angle, as we learned before, that splits it in half, is 180 degrees. Is that correct? So everything above this line is 180 degrees. Everything below is also 180 degrees. So let's look. This angle right here, ABC, when we combine it with this angle next to it, the adjacent ABD, when we combine these two angles, add them together, they're going to equal one straight angle, which is 180 degrees. Two angles that equal 180 degrees are called supplementary angles. Two angles that when you put together, they equal, when you put together their sum, when you add them together, their sum is 180 degrees. Okay? Now there's another definition as well. Two angles whose sum is 90 degrees. If we put back our prime meridian here, this angle and this angle, when we add those together, they would be called complementary. Complementary angles are two angles which equal 90 degrees if you add their sum. So, based on this information, you should be able to tell that ABC and DBE are vertical angles. Good, thank you. And ABC and ABD are adjacent angles. And when you add two adjacent angles together and they equal a straight angle, they're supplementary. They equal 180 degrees. Only if they also equal a straight angle, which is a flat line.